Hello everyone, I'm Yağmur Atuk. I'm from the Department of Electrical and Electronics Engineering, and today I will be presenting my Physics 101 lab project, Mass's Effect on a Projectile's Range and Maximum Height. My project's objective is to prove that mass does not have an effect on these two variables. Starting off with the theory of the project, we know that the range of the projectile motion could be formulated as v cos theta t, and the maximum height reached by the projectile could be formulated as v sine theta t minus gt squared over 2. These equations are derived from the kinematic equations for a two-dimensional motion. It could be seen in these two equations that m is not present and therefore does not have an effect on the range and the maximum height. But since mg is the only force acting on the projectile, it may create the wrong intuition that m does somehow have an effect on these two variables. But this could be proven wrong with Newton's second law of motion, which suggests F equals ma. And if we equalize ma to mg, in our situation, we can see that the m's cancel out each other and a equals g. And there we can see that m does not have an effect on these two variables. I used 3 balls, equal in size but different in mass. The first one was plastic, the second one was wood, and the third one was glass. I set up the launcher 55 degrees over the horizontal and 0.19 meters away from the left end of the table. I then placed the camera opposite to the motion of the balls and a cardboard scale of 0.5 meters. I chose the most accurate landing points, and I started analyzing the video footages by Vernier Video Analysis app. I used the cardboard scale to conduct the graphs in appropriate units, and here are the graphs. For error calculation in my experiment, I used the root mean square error method, and it could be written like this. Observing the x components of displacement and velocity RMSE values of the balls, it could be seen that the glass ball had the highest displacement RMSE value. This may have been caused because it was the least homogeneous amongst the balls as it had scratches over it, and because of this, it was possibly exposed to higher air resistance. Looking at the x velocity RMSE values, it could be seen that the wooden ball had the highest RMSE value, and this was highly caused because it was the least distinguishable ball from the background, and therefore it was harder to track that ball. Looking at the y components of displacement and velocity RMSE values of the balls, it could be seen that the glass ball had the least displacement RMSE value compared to the other balls, as it was the most distinguishable ball from the background, and as it flew slower, it was slightly easier to track that ball. And looking at the y velocity RMSE values, it could be seen that the wooden ball had the highest RMSE value amongst the other ones, as it was again the least distinguishable ball from the background and it was harder to track it down. The errors that occurred in this experiment were caused because of air resistance, friction, differences of homogeneity of the balls, and the launcher bouncing back each time I threw the balls, and it not being able to throw all the balls in equal velocities. Digitally speaking, since the balls moved too fast, the auto-tracking feature of the Vernier Video Analysis app did not work, and I had to manually track the balls frame by frame. And also some of the values on the graphs were not precisely written, and I had to estimate those values. And the colors of the balls contributed to their distinguishability in the video, and that caused me to choose more or less accurate points of motion. And lastly, the camera angle may have changed each time I pressed the start and stop button. But overall, the error was small and the results were consistent with the theoretical expectations, and it could be said that the experiment was successful and it proved that the mass does not affect a projectile's range and maximum height. Thank you so much for listening to me.